It's not like Khan Academy or something like that. Today is going to be pretty simple. We're going to look at triangles because that's what trigonometry is about. It's about triangles. And we're just going to kind of name triangles, and we're going to get introduced to something called the trigonometric ratios, which is what we're going to use every single lesson, basically. Warm-up number one, I don't overly like. So you're going to notice we kind of cut out chunks of this because I find it just confuses people more than anything. Plus, back in the day, we used to do trig with like a textbook. You'd have like this big chart of things. It was craziness. Now it's not so bad. We have our calculators, a little bit easier. So we're going to skip to page 200. We're going to talk about triangles, the type of triangles we use. The first thing that we need to know is that when we do trig in this unit, you must have a right angle triangle. Right? So a right angle triangle means that somewhere in your triangle there's a 90 degree, like that, like it comes to a perfect square. We represent the 90 degree triangle with that little square in the corner. And that means that corner is 90. You can't do any of the trig we're going to learn without a 90 degree in it. All right, so if you have a question where it's not 90 degrees, somehow you're going to have to make it 90 degrees. Yeah, and we'll get more into that in the future. Like every triangle you see for the next 3 days will all be 90 degrees. But later on in the unit, it's not. Awesome. When you have a 90 degree triangle, you're able to name the sides of that triangle. When you're naming the sides of the triangle, it's based off of what angle you're talking about. So for instance, if you look at that triangle I have here, they've labeled one of the angles. Right? They've put a little thing there and they've called it X. You base the naming of your triangle off of the angle that you're talking about or referring to. In this case, it's X, that we're always going to be referring to. All right, the first side that we like to name is called the hypotenuse. I like to name that one first because most of you remember what a hypotenuse is. The hypotenuse is the longest side of a triangle. Right? The longest side of a triangle is always across from the biggest angle. In a 90 degree triangle, it's always the 90 degree. So if you look at the 90 and you look across from it, this is the hypotenuse. Oh, I usually just call it H, but I'm going to have to call it actual hypotenuse right now. Just so you don't miss it. Hypotenuse. Good thing the spelling of hypotenuse is right here, else I wouldn't know. There we go. So the side across from the 90 is called the hypotenuse. It's the larger side. Most of you guys get hypotenuse every time because you're really good at it and you've seen it before, right? The other two sides you never really had names for. Now we're going to have names for. All right? And again, it's based off of the angle they gave you. So if you look at this angle, X, and if you were to draw a line coming straight out of X and figure out the side that's opposite of it. So if you kept going, it's over here, right? We call that the opposite side. Really original. Opposite does have an E at the end of that. Awesome. The third side is called the adjacent side. So when I'm naming a triangle, I look for the hypotenuse, because everyone's good at that. I go across from the angle I'm talking about, and I name that opposite. And the third one I would just call adjacent. Adjacent means like beside. If you're adjacent to something, you're next to it. So adjacent would be right beside the angle you're talking about. That's the best way to think about it. Those three sides and naming triangles is going to be like the first thing we do on every question. So if you're struggling with naming triangles, it's going to be almost impossible to do this unit. That's why we're going to spend a whole day on just naming triangles, right? So that we all get it straight. All right. They've talked about it right here. Right? They just named the same sides the way I just did. They just did it in their fancy method. So over down here, we're going to look at these two triangles. I'll do the first one with you. You'll do the second one on your own. We're going to name the sides. All right, looking at this triangle right here, it's a 90 degree triangle. I know that across from a 90 degree triangle, across from a 90 degree, is the hypotenuse. I just put HYP because I'm lazy. And as we get going further, I'm just going to put h. The second side length I try to name is across from the angle that they've given you, or named. If you look, they've named angle x, so we're naming this triangle based off of that. Across from that is the opposite. I'm just going to put OPP, opposite. The third side length is the adjacent. Awesome. Take a look at triangle B and try to name that thing. So label all three sides. I'll give you like a minute. First side I go for is the hypotenuse. It's the easiest side to get because it's always across from the 90. So I'm looking at this guy. Here's my 90 because they've labeled it with that little square. Across from it is my hypotenuse. The next thing I do is I figure out the angle they've given me, or the angle they're talking about this question. In our case, it's this angle up here, x. And notice that the other angle has nothing with it. And that's how I know I'm naming it with this in mind. Across or opposite of that angle is called your opposite. And lastly, your third side is the side of the angle they're talking about. It's called the adjacent, ADJ. Fantastic. All right, we use those sides to create something called trigonometric ratios. I just don't like this overly. Let's go to. Yeah, we'll talk about this page because it's here. And I don't want you to read that one day and be like, what the heck is he talking about? The trigonometric ratios. So, if you take side lengths and you divide them by each other, they found a long time ago in math that it would always equal out to a certain ratio. Okay, so based on an angle, one side length divided by the other side length would always equal a decimal. It would be similar. So, for instance, if you had a triangle and this side was 4 and the other side was 2, and then if you just scaled it up and made it 8 and 4, it would still create the same ratio when you divided each other. It's a really quick way in math to figure out different side lengths when you know an angle. Right, those trig ratios you're going to need to know. You're only going to need to know the first 3 of them. There's technically more than 3. There's technically 6. You're not going to get tested on the inputs. Okay, those kind of come in later on in mathematics. You're just going to get tested on the first 3. These are called the primary trigonometric ratios because it's the first 3, like primary colors. Right? Those ratios are called the sine ratio, the cosine ratio, and the tangent ratio. And you're going to hear me talk about all 3 of them all the time. I'll usually use short abbreviations. Okay, so I'll say sine, cos, tan. That's how you're going to hear me refer to them mostly. Right, the sine ratio is the opposite side length divided by the hypotenuse side length. So if you're looking at a triangle like we just did above, if I was talking about the sine ratio, I would do opposite, which would be this side, and I would divide it by the hypotenuse, which would be that side. And we don't have lengths yet, right? So we're just talking about side lengths. The cosine ratio is adjacent divided by hypotenuse, which would be the adjacent side length divided by the hypotenuse side length. And the tangent ratio is the opposite divided by the adjacent. And these things are going to help us find angles, right? That's what we're going to do with them. You are going to have to remember those side lengths and those ratios. To do that, we have like a really simple little saying. I don't know what, like, if you talk to anyone who's ever done trig, they'll know this saying, even though it's a kind of a ridiculous saying in my mind because it doesn't mean anything. But the saying is right here. Okay, that's SOHCAHTOA. So the second step to every question, not every question, but most questions, will be using SOHCAHTOA. Now we're going to name triangles, and we're going to use SOHCAHTOA. What SOHCAHTOA is it's a fancy way to remember your ratios. So, SOH means sine equals opposite divided by hypotenuse. sine equals opposite divided by hypotenuse. Right? Which was the ratio. Sine opposite divided by hypotenuse. Cos, or cos, sorry, means cos equals adjacent divided by hypotenuse. And so you can see how this is helping us a little bit just to remember what our ratios are. The last one, TOA, would stand for tangent. So that would be tan equals opposite divided by adjacent. I'll show you another way to write out SOHCAHTOA. I'll always write it like this, and you'll see why. But some people do prefer to write it like this. So, TOA. You'll learn in a couple days why I like to do it with the straight line. However, I do understand some people prefer it this way because then it shows you what it is, right? Sine equals opposite divided by hypotenuse. And they remember the little division. So if you prefer to write it that way, that's fine with me too. Fantastic. We're going to go back to class example 1, which was naming those two triangles above. And we're going to write out what the sine ratio, cos ratio, and tangent ratio actually were. So the sine ratio for example A. If you look up at example A, you want to do opposite divided by hypotenuse. Opposite was this side length up here at the top of the triangle. Does anybody remember how we would name that side of the triangle? We would name it based on the names of the ends. So this side of the triangle is from D to E. So we call it DE. So we would want opposite divided by hypotenuse. So it's DE divided by, if you were to name the hypotenuse, it would be from here to here, that would be EF. Right, from E to F. So our sine ratio for question 1 would have been DE divided by EF. And in the future, you will have numbers there. The cosine ratio. So if you look up, cosine ratio is the adjacent side length divided by the hypotenuse side length. Looking at this guy, the adjacent side length. The adjacent side length was from D to F, right? It was this side length right here, D, F. So if I wanted to do cosine, adjacent divided by hypotenuse, it would be DF divided by EF. And the last one is TOA, or tangent ratio. Tangent is equal to the opposite side divided by the adjacent side. Looking at my triangle, the opposite side was DE. The adjacent side was DF. So it would be side DE divided by side DF. All right, I want you to try to fill in the ratios the same way we just did. So with side lengths like this. For the second triangle, try your best to name that second triangle, to name those side lengths too, right? From one point to the other point. And it usually goes alphabetical. You notice how I went DE instead of ED.
Does it matter?
It doesn't matter. It doesn't make a difference. It's just typically you'll see it alphabetical. Okay, so see if you can name those side lengths and then if you can write them in their ratios. Give it a minute or so. If we're looking at these triangles and we're trying to do the ratios, we got to first name the triangles. And name the side of it, right? We've already labeled it as opposite, adjacent, hypotenuse. That's fantastic. And now we just need to have a way of referring to them from point to point. So for instance, the hypotenuse would have been V to T. You could do VT or you could do TV. I'm going to do TV because I think that sounds cooler. Right? Doesn't matter as long as it's from one point to the other point describing that side length. The adjacent side would be T to S or S to T. Right? It doesn't matter which way you do it. This side length would be VS or S to V. Again, doesn't matter which way you do it. But that's how we describe side lengths from one point to the other point. Imagine that line. From one point connecting to the other point. Awesome. If you filled out your ratios using that info, opposite over hypotenuse for sine would have been SV, that was opposite, right? Divided by hypotenuse with TV. I don't want to scroll back up. I got that right? That's the opposite of the hypotenuse? Good. Okay, and again, if you have your letters flipped, it's no big deal. So if that's VS, that's fine. The cosine ratio would have been the adjacent side divided by the hypotenuse side. So if you look back up, the adjacent side would have been TS or ST divided by hypotenuse, which is TV. Adjacent being ST, hypotenuse being TV. The tangent ratio would have been the opposite divided by the adjacent, so opposite is SV, and the adjacent is ST. Those are called your primary trigonomic ratios. Right? You are going to hear it called that every once in a while. Like you're going to get a test where it says, state the primary trigonomic ratios. These are the primary trigonomic ratios, and these are the ratios for a given triangle. And so I said, what's the ratio for this triangle? The sine ratio. You would say this side divided by this side. Probably with numbers, right? But you might even be with letters. I just want you to hear that terminology a few times because I am going to use it on tests. Awesome, let's try with numbers. So we got this triangle over here. It's been labeled with numbers this time on the side lengths. If you want to use the primary trigonomic ratios, you need to name your triangle. Your three side names are hypotenuse, opposite, and adjacent. I always name the hypotenuse first. So looking at this triangle, I notice that my 90 degree is right here. Directly across from my 90 degree is my hypotenuse side. So my hypotenuse side is equal to 20. The next side length I name is my opposite side. The opposite is based on the angle they've given you to work with. So when we look at this question, they've given me angle A to work with. The opposite side is the side length that's the complete opposite of the angle they've given you. Opposite side. The third side is the adjacent side, or it's the one that's right beside the angle they've given you. The adjacent goes right there. Awesome. Let's see if we can figure out the primary trigonomic ratios for this triangle. The first primary trigonomic ratio I'm going to do is the sine ratio. The sine ratio equals the opposite side divided by hypotenuse side. Looking at this triangle, my opposite side is 20. My hypotenuse side is 29. So my sine ratio is 20 divided by 29. My cosine ratio, according to my formula, the cosine ratio is adjacent divided by hypotenuse. Looking at that triangle, my adjacent side is 21. My hypotenuse side is 29. So my cosine ratio would be 21 divided by 29. Lastly, my tangent ratio is opposite divided by adjacent. the opposite side is 20, the adjacent side is 21. Those are the primary trig ratios. Fantastic. I don't think this book does it. I don't think any of our note packages have ever done it. I've always just discussed it. You could always work your way backwards. Okay, so for instance, imagine they gave you this question. What's that? But they didn't give you numbers. And instead, they gave you the trig ratios. Okay, so they said, okay, sine equals 20 over 29. What they're telling you is two side lengths of that triangle. So I could come over to this triangle and be like, sine is opposite over hypotenuse. That means they've told me my opposite side is 20. And my hypotenuse side is 29. See how the trig ratios are giving you side lengths. So you could work the other way too. We almost 99% of the time go from triangle to ratios, but you could work it backwards. In Math 20 in particular, you're going to start to go backwards a lot. Right? They'll give you the trig ratios, and then you build the triangle. In Math 10, we typically give you the triangle, and then you build the ratios. Right? But you might see it the other way too, just as a bit of a challenger. It's good to just understand what things mean, right? It'll help you out. All right, a little more naming. We're going to talk about the trig ratios, so sine, cosine, tan. We're going to talk about the short abbreviation for them, so and how we properly write that. So looking at this first question, we've got a triangle, PQR. We'll notice that they've given us an angle. We'll also notice it's 90 degrees. The first thing we do on any given triangle is we name it. Okay, so we're going to name it opposite, hypotenuse, and adjacent. I'll give you 10 seconds to try to name that triangle. So try to name opposite, hypotenuse, and adjacent, because that is something you're going to need to be good at. Okay, looking at this guy, the first side length I would name would be my hypotenuse. My hypotenuse is always across from my 90. My 90 has a little square in it. Across from there, that's my hypotenuse. The next side length I name is based off of the angle that they labeled for me. They labeled x. So the opposite side from x, if I drew a straight line to the opposite, we call that opposite. The side beside it, or adjacent to it, is called adjacent. Alright, so hopefully you're getting those right. Just double check your work right now. If it's not right, just correct it. Otherwise, you're going to look back at your notes and be really confused. Those should be your three side lengths. Awesome. Let's talk about the primary trig ratios for this. Now, in the previous example, I said sine ratio equals, which is kind of silly to have to write all that out. So the way we would shorthand that, instead of saying sine ratio, I would write it as this. I take the first three letters, so I just go S-I-N. And then I would put the angle that I used to name my triangle. So looking at this, the angle I used to name my triangle was x. So I would go sine x. And that would tell me I want the sine ratio based on angle x. You will see, I'll typically write it like this, brackets here. Sometimes people put brackets, sometimes they won't. I'll try to always put brackets. It just really signifies that the x is an angle and it's not part of the name. Like it's not sine x, it's sine of angle x. So I'll try to put brackets just to break it up. Okay. So you'll notice down here, they have it right here. This means the sine ratio based on angle x is the opposite, which is 3, divided by hypotenuse, which is 5. Opposite hypotenuse. You can do the same thing for the other two trigonometric ratios. So looking at this guy right here, That means the cosine ratio based on angle x. Looking up here, cosine ratio is adjacent divided by hypotenuse. Adjacent is 4. Hypotenuse is 5. Just a shorter, quicker way of writing it than writing cosine ratio. The last one, tan x. That means the tan ratio based on angle x is opposite divided by adjacent. Opposite is 3. Adjacent is 4. Those would be your primary trigonometric ratios, just a quicker way to write it. The angle is really important, okay? Because technically you could work with either angle, and they could technically name either angle, and you'd have to work with that. Down here, oh, not quite there yet, sorry. We're going to work with both angles in a little bit. We're not there yet. We're going to try this. So we're going to name the 3 trig ratios using the shorthand form for the triangle given to the right. The triangle has not been labeled for us, so let's label the side lengths to start. Hypotenuse is across from the 90, it's right here. Opposite is across from the angle you're working with. Across from A is opposite right here. And the adjacent is the third side, it's right here. All right, sine A. That means the sine ratio based on angle A. Just a reminder, the sine ratio is opposite divided by hypotenuse. The opposite side is 30. The hypotenuse side is 34. B, the cosine ratio. Just a reminder, cos is equal to adjacent divided by hypotenuse. So the cosine ratio based on angle A is 16 divided by 34. And lastly, the tan ratio. A reminder that tan is equal to opposite over adjacent. In this case, the opposite is 30 divided by the adjacent, which is 16. Easy enough, right? Name the triangle, remember the formula, the ratios are just numbers divided by each other. Now there is a little bit of a trick to this, because if this was a multiple choice test or any test, and I said the sine ratio equals, there's a good chance that 30 divided by 34 is not the right answer. The reason 30 divided by 34 is not the right answer is that is not written in simplest form. Right? Simplest form means like reduced right to the smallest fraction. You know how we say things like 5 divided by 10 is the same thing as 1 over 2? Right? Reducing our fractions, and we've done it in other units. You're going to have to do that for this unit. Your calculators can do it really easily for you. So on these big fancy calculators, we call it math frac. Okay, so if I took a ratio like 30 divided by 16, I could find the equivalent ratio by going 30 divided by 16 in my calculator, hitting enter, and then hitting math right here. And the first option is frac. Hit 1 or enter on that, and hit enter again. And your calculator will tell you the lowest fraction. In our case, the lowest fraction is 15 over 8. So the tangent ratio is 15 divided by 8. If you're not using one of these calculators, you've used MathFrac at some point in previous units. If you forget how to do it, just ask. Remember, we'll figure it out on those calculators. That's why, again, once you get one of these, and then we're all following the same rules, which is kind of nice. But if you don't have one yet, we'll chat about it. There is a way to do it without a calculator. The way you do it without the calculator is you figure out the biggest number that divides into both numbers. So, for instance, 30 and 34 can both be divided by 2. When you divide both of them by 2, it gives you 15 divided by 17, which would be the simplest form ratio. The last one, you have 16 and 34. Both of those are divisible by 2, just 2. So it would become 8 divided by 7. You are going to have to write it in simplest form. Okay, so you're going to have to get used to simplifying those fractions. Awesome. I want you to try that's example 6 on your own. Don't worry about reducing it or anything like that, just write the fractions. Okay, so try to write all 3 ratios. If you need to, use SOHCAHTOA to help you remember what sides are divided by what. But try the whole question on your own. Okay, so looking at these guys, the angle matters, right? And we've talked about that. So when it says cos of A, they want the cosine ratio based on angle A. So you had to name your triangle based on angle A, which I've done in the red, right? The opposite side is 12, the adjacent side is 5, the hypotenuse is 13. I've labeled it in red for angle A. Cosine wants adjacent divided by hypotenuse. Adjacent is 5, hypotenuse is 13. By changing the angle from A to B, changes your answer. So even though it was cos A and cos B, and they're both cosines, the answer changes because it's based on a different angle, a different reference, right? So you have to relabel your triangle based on angle B, which I've done in purple. The cosine for the blue one, the cosine for B would be 12 divided by 13. Adjacent is now 12, hypotenuse is still 13. Labeling your triangles is so very important. Lastly, we'll do tan B and sine A. So tan B means based on angle B. Based on angle B, tangent would be opposite 5 divided by adjacent 12. Sine A is based on angle A. Opposite over hypotenuse. The opposite for angle A was 12. The hypotenuse for angle A was 13. Those would be your trig ratios. Fantastic. In the future, we're going to do a lot of trig, and you have to be able to name your triangles and understand what we're talking about 100%. Right? You can't label your triangle wrong or the whole thing goes wrong. Okay, so you have a good 20 minutes to practice this stuff, like naming all your triangles. I think it's super important to get your practice done for this lesson.